Alright guys, here we go finally. So hopefully you guys all have your little notes here. And yeah, let's get started. So some of this hopefully is review, but if it's not, no big deal. So let's start with the basics. A unit circle is a circle centered at the origin. How does the equation of a unit circle look like from your algebra? Probably not an algebra 1, probably algebra 2 or geometry when you were in one of those two subjects. The equation of a circle centered at the origin looks like this. X squared plus y squared equals r squared. Where r is the radius. R equals radius. You might have seen it like this. X minus x naught squared plus y minus y naught squared equals r squared. Or you might have, depending on the textbook, x minus h squared plus y minus k squared equals r squared. And there's also one more. They're all the same. They all mean the same. They're all centered at the origin. You could also look like x minus h over rx squared plus y minus k over ry squared equals 1. And if rx equals ry, you have a circle. If rx is not equal to ry, then you have an ellipse. Does any of that look familiar to you guys? Oh, none of that looks familiar? Okay, no big deal. Then there it is. That's a y, not a 4. It just came out weird. I wonder why that little section... There we go. For whatever reason, there's a little section where it just likes to do squiggly. Instead of h and k, sometimes they call that x naught and y naught. It means the same thing, guys, so don't freak out. If you go to Khan Academy and they don't have one of these formulas, maybe they write it like x minus x naught over r squared plus y minus y naught over r squared equals 1. They all mean the same thing. These are all equations of a circle centered at x naught comma y naught or h comma k with a radius of r, except for the one that says rx and ry. If rx and ry are different numbers, then you don't have a circle. But yeah, we'll talk about those when we get there. So none of that looks familiar to you guys? Oh man.
The third one that you did, kind of a little, like h and k, so that was a little familiar, but
Okay. Yeah, we'll apply it, not today, but we will definitely use it in the future. So we're going to focus on some special angles, guys. So let's see, what should we do first? Yeah, let's draw, let's see, how much room do we got? Do I talk? Yeah, let's see, I have the unit circle here. What do I want to do first? Okay, I know what I want to do. Let's talk about the unit circle. So there's some special angles to this unit circle, and I tried to make it perfect, but it's not. A unit circle has a radius of 1, and it's centered at the origin. And here is how it looks. From the origin, this is 30 degrees. And what am I actually measuring? This angle here is 30 degrees. So that's actually what I'm measuring for all of them. And then I jump 15 degrees from there. And then this one's 45. And it's really this that is 45 degrees, right? And then I go another 15 degrees. And I call that 60 degrees. And I'm going to continue with that pattern. You're going to be 30 degrees away from the axis, so this is 90 degrees. So what's the pattern? From the axis, you're 30 degrees away, and then you just go 15, 15, and another 30. And you just keep with that pattern. So 90 plus 30, 120. Then you do another 15, 135. You do another 15, 150. And then there's your, at 30, there's your 180, which you guys already knew. 210, 225, 240, 270. And sorry if it's not perfect. Eventually it'll get perfect. 300, because I'll give you like the actual circle, right? 315. 330. And then once you do a complete revolution, I'm going to put 0 and I'm going to put 360. Nothing crazy? Okay. Don't worry, guys. So let's go to this page here. And it says, because of these special angles, we can derive the coordinates by looking at special right triangles 30, 60, 90 and 45, 45, 90. All right. So I want you to focus on this triangle, right? This angle right here. I'll put 0 degrees here. You know what? Let's go ahead and fill in the stuff that we do know, like for a fact. We know that the radius is 1. So then that if the radius is 1, that means that coordinate is 1, 0. This on the right means radians, so that's 0 radians. And then we know, obviously we just did these 3, but don't fill it in yet. That's 90 degrees, which is the same thing as pi over 2. And this has to be 0, 1. So at the moment, you just have that much. We're okay so far? All right. I want you to focus your attention to this triangle in red. Do you guys see that triangle in red? I'm trying to do a British accent there, but all right, let me see. Can I copy it, duplicate, and then can I move it? I just did that one line. That's fine. Okay, there's that one line that's the same as the hypotenuse in the bottom. And here's my triangle in red that I have in the bottom. I tried to do that same triangle. I tried to do copy paste. It didn't work. I'm sure it will work if I like use my mouse. All right, that triangle is the same one that I just copied right now a little while ago, right? This is what's 30 degrees. And this hypotenuse is length of 1 because it's a radius. What I'm trying to figure out is what is this horizontal displacement? We're going to call that an x value. And what is this vertical displacement? We're going to call that a y value. I want to know what that x and y is. So here's how we're going to do it. We see it's a 30, 60, 90 triangle. And we remember, oh yeah, we've done a whole bunch of these. Hopefully you also remember it from the quiz that you took a little while ago, the UH quiz. And you're like, oh yeah, that's n squared root of 3, and that's 2n. These are just properties. Hopefully you remember those properties from geometry, but if you don't, we're giving them to you here. Are we okay with that right there, guys? All right. Since I know my hypotenuse is 1, I can say 2n equals 1. So I'm going to go here to the side. I'm going to write 2n equals 1. I'm going to grab my short leg by dividing by 2. What's my short leg? This y is the short leg. So divide by 2. So now I have that n equals a half. So there it is. Y equals a half. Do you see how we got it, guys? All right. So now how am I going to get my long leg? Well, according to this, the long leg is that half multiplied by square root of 3. So that x is your long leg, n square root of 3. So I take my n, which was a half, and I multiply by square root of 3. Now you can leave it like that, but I prefer square root of 3 over 2. Now when you take your UH quizzes, they're going to probably have the 1/2 with the square root of 3 on the side. Square root of 3 over 2 is what I prefer, but no big deal. They're both the same. Are we okay so far, guys? All right. Now that you've seen that, remember, that's that same triangle that I have down here. I tried to do the copy-paste feature, but didn't work for me. This distance here, we said that was an x distance. That horizontal distance was square root of 3 over 2. Because that's the distance from the origin to whatever x value I'm at. Does that make sense, guys? All right. What was this y value? 1/2. So there it is. We figured out that coordinate there, square root of 3 over 2, comma half. None of this memorized or blah, blah, blah. Like, we did it. We did it, guys. So is there another 30, 60, 90 triangle in here? Yes, there is. I'm gonna label that 30 degrees now. That's what's really 30 degrees here. There's another 30, 60, 90 triangle. I'm going to do it in red because it's the same triangle. It's just... Let me erase that X there. Do you guys see that triangle in red? So that triangle in red there, guys, It's the same 30, 60, 90, but this guy is 30 degrees up here. So do you see how the angle just switched? So what's a 60 degree? This one. That's 60 degree. So if the radius is still 1, if the hypotenuse is still 1, what's going to happen to my coordinates now? Instead of the x being square root of 3 over 2, it's going to be the y that is square root of 3 over 2. Yes or no? Yeah, because now my y value is this long leg, guys. This one right here that I'm doing in green, that's your long leg. That's the same as this one here in green. And you guys told me that one in the bottom in green was square root of 3 over 2, right? So now this one right here in green, that long one, that has to be square root of 3 over 2. It's a 30, 60, 90 triangle. Does that make sense to you guys or no? Perfect. So what do you think my x-coordinate is? Yeah, it's a half, guys. I would use that little dash as a fraction thing so you could put, it makes it look neater. What do you guys think so far? Pretty cool? What's up, Ocean? Oh, the horizontal distance, anytime I have, if I call this the origin and I have something like this, this is just horizontal distance, so that's an x. This is vertical distance, that's a y. And this coordinate has to be x comma y, because I moved to the right and then I moved up. That makes sense? So if I call that the origin 0, 0. Any other questions, guys? All right, so there it is. We figured out that one. Now we got to figure out one more. So I'm going to take my colored pencils and I'm going to use the color blue. So I'm trying to color code to try to have good notes here, guys. So here it is, my triangle in blue. And whatever you see in blue is just for that one triangle. So if you have colored pencils, or if you like to color your notes, or use a different colored pen or something. So here we go. And don't worry, I'm going to go slow. This is a 45 degree angle. And I have a 45, 45, 90. How much space do I have? I don't have space there. I got space kind of right here, so I'm going to write it here. 45, 45, 90. I'm going to say n square root of 2. Are we still okay? All right. I'm not going to draw it as big, guys, but trust me, it's the same triangle. So here's that triangle in blue. I'm going to draw it right here so there's less clutter. And you're like saying, Chavez, it's not even the same size. Well, pretend it is. That's 1. This is 45 degrees. And that's 45 degrees. And I'm trying to do this triangle. That's this triangle. It's just that I don't have the space. Are we okay so far? All right. What I'm trying to figure out is this distance. That's some x coordinate. And I'm trying to figure out that distance. That's some y coordinate. The way I have this model up here with the properties, that means that x has to equal n, and that y also equals n. Are we still okay? All right. My hypotenuse is a 1, and according to this property, the hypotenuse has the property n square root of 2. So I'm going to write n square root of 2 equals 1. I need to get n by itself, excuse me, because that's what I want to figure out. So I'm going to divide by square root of 2. And you get an answer that's 1 over square root of 2. The acceptable answer is a rational denominator, which means that you do not have a radical in the denominator. So here it is. I'm rationalizing the denominator. Multiply by square root of 2 over square root of 2. That's just 1, so anything times 1 is itself, right? So you're going to get square root of 2 over 2. Because square root times square root, the square root goes away. You just have 2. So both the x and y are square root 2 over 2. How do you feel? So come over here, write square root of 2 over 2, square root of 2 over 2. See, we're doing so good, guys. Well, I don't know. We haven't asked any questions, so maybe I think we're doing good. How do you guys feel? Do we feel all right? All right. I see that I have a blank here that I forgot to put in. Put in that 60 degrees. There it is, 30, 45, 60. We got the whole first quadrant pretty much done. So I think we're ready to go down here. I think we're ready. The last page. Yeah, the third page is intentionally left blank. What's up? What's up? Oh yeah, we're going to go over that in a little bit. Not yet. All right, we're going to fill in this unit circle. It's perfectly done. No one has to draw anything. We're going to fill in what we know. What do we know? Let's see, 0 degrees, 30, 45, 60, 90. Let's just go ahead and just keep going, right? And maybe you're thinking like, Chavez, you should have told us to fill this in first. Well, you know, practice makes progress, so now you're a better person for it. 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then 1 revolution, 360. Are we okay with those? All right, let's fill in the coordinates that we know. So I guess let's do the easy ones first. 1, 0, 0, 1, negative 1, 0, 0, negative 1. The most common mistake is you guys toggle those. So you call the x y and you call the y x. All right, let's do the ones we just derived. At 30 degrees, square root of 3 over 2, 1/2. At 45, square root of 2 over 2, square root of 2 over 2. And at 60, toggle the ones that you had at 30. 1/2, square root of 3 over 2. By toggle, I mean switch them. Are we cool? What's up? Bless you. Yep. Now, it's even better if you know remember from your algebra, your symmetry, right? In quadrant 2, what's negative and what's positive? There it is. So start filling in quadrant 2. So just turn the x into a negative. Negative 1/2. Square root of 3 over 2. All I'm doing is everything symmetric about the y-axis, guys. In 135, the x is negative. Square root of 2 over 2. Square root of 2 over 2. Negative square root of 3 over 2. 1/2. In quadrant 3, are both of them negative? Yes. Symmetric about the x-axis. Keep it the same. So negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, negative square root of 3 over 2. And in quadrant 4, what is negative? The y's. Symmetric about the x-axis. So the very first one at 300, positive 1/2, negative square root of 3 over 2. Or you could also do it symmetric about the y-axis, doesn't matter. Square root of 2 over 2, negative square root of 2 over 2. And then square root of 3 over 2, negative 1/2. So now you should have a full circle like that. Doesn't that look pretty, guys? Alright, here we go with the radians. You guys ready? So hopefully some of you have observed, we haven't filled in the whole circle. We're really close. We're really close to filling it all in. So what do I have left? The radians, which is the same as degrees. The only difference, it's a way to measure an angle. It's just a different unit of measure. Cool? All right, here we go. This one's the obvious one. I haven't moved. So at 0, you're still 0. 0 radians. And then if I've done 1 revolution, that's how many radians in a revolution? So for the one right at bottom, for the 360, I put the 2 pi in there. So hopefully you remember the easy ones. At 90 degrees, that one is pi over 2. At 180 degrees, that is pi. At 270 degrees, that is what? 3 pi over 2. So there it is. We got 4 of them now. So what is it at 30 degrees? Well, let's calculate it. Let's see if we can do it by hand. So on the third page, I intentionally left it blank. Maybe by writing intentionally left blank, it's not blank, right? But I'll stop. So take, let's see, 30 degrees. How do I convert degrees to radians? Take a degree, multiply by pi over 180. Let's see if we need a calculator for this. pi over 180. No, I don't think we do. 3 goes into 18 how many times? Yeah, so 30 must go into 180 6 times. So we got pi over 6. That's what you're going to fill in. So go over here and type pi over 6. Do the same thing for 45. Let's go over here so we can keep our nice and neat. 45 degrees times pi over 180. Well, 45 plus 45 is 90, and 90 plus 90 is 180. So that is 1 out of 4 sections. So pi over 4. Right, 45, 45, 45, 45. If I add them together. So come over here and write pi over 4. At 60 degrees, let's see, 60 degrees times pi over 180. 6 goes into 18, so pi over 3. Yay, we got the first quadrant. Let's keep going. Let's see. Can we continue with the same pattern for quadrant 2, I guess? I guess we can, but watch. Let's see. 120 degrees times pi over 180. 6 goes into 12. Twice, right? And then 6 goes into 18. So 2 pi over 3. I'm thinking about greatest common factor. So 2 pi over 3. Are you shocked that it's 2 pi over 3? Let's do one more. Maybe you'll see a pattern. So let's see. What was the next one? 135 times pi over 180. Oh man. I don't know if that one. I don't know if that one has a. If I can see. Can you guys see it? I'm going to use my calculator. That one did us through. I guess we could just keep reducing it, right? 5 goes into 135, and then 5 goes into 180, and then that, like, what goes into that? Oh, look, here it is. Okay, I'm going to clear it. Pretend that you didn't see that. 135 over 180, and it gave me a perfect 0.75. If I turn that into a fraction, I get 3/4. So this must be 3 pi over 4. Okay. Let's not calculate the 150 by hand. Let's observe something. Let's see if we can figure something out here. You're close. I heard 1/6 pi, and then you're looking at that pi. So if you're 1/6 pi away from a whole pi, where am I at? 5/6 of pi. How did we get that? I think, did you hear what I said? If you're not here where the whole pi is at, then where you at? Also, I can't do it. I tried to do that TikTok thing, but I'll stop. All right, I'll stop, guys. I apologize. I won't do that ever again. All right, here's what I'm trying to say. So don't write this down. Just listen right now. Just listen. Everyone knows that, well, I hope, that from here to here, that is pi. Don't write anything down. Just listen. Yes or no? And then some of you are starting to figure out, you're looking at it, and you're like, wait a minute, Chavez. This distance here, that's the same as this. That's like your reference angle, right? And that distance in blue, that was pi over 6 over here in this one. So if this is pi over 6, that means I'm 1/6 away from a whole pi from doing that. Do you guys see that? So if you're 1/6 away from a whole pi, then this must be 5 pi over 6. Pi minus pi over 6. Oh, common denominator, 6 and 6 is 5 pi over 6. Cool or not cool? And the same thing works for all of these. That's pi over 4. This distance is pi over 3. So look, pi over 3 from a whole pi is 2/3 of a pi. Pi over 4 from a whole pi is 3/4 of a pi. That's what's beautiful about math, all these patterns. You don't have to work really hard You can just look at the patterns, and the patterns can give you all the answers. You guys don't think that's cool? All right, write that thought down in your notes, guys. Write that thought down. And we're going to see how smart you guys are. What's up? No, at least you got $1, right? I mean, oh, you got 4. Oh, you're winning, miss. All right, check this out, guys. Let's see how smart you guys are. You can continue. It will work. Multiply all those degrees by pi over 180, and you got it. You'll get the right answer. But using that same logic that we just said, we can figure out what this radian is. That radian is 1/6 more, 1/6 pi more from pi. So what is it going to be? 7 pi over 6. In a little bit, I'll give you the, if you want to be a robot, I'll tell you what to do. But I don't want you to be a robot. What about the next one? The next one is going to be, it's the same thing, guys. It's going to be 1/4 pi, or pi over 4 more than pi. Pi over 4 more than pi. 5 pi over 4. What's this next one? Well, let's see. Look at quadrant 1. That would have been pi over 3 as my reference angle. So I'm pi over 3 more than pi. 4 pi over 3. Oh, now how do you do in quadrant 4, Chavez? There's 2 ways of thought. Let me zoom in on quadrant 4. You can either think of it as this is how far you are away. So let's look at the 300 one. That distance is pi over 3 away. So you're pi over 3 away from 2 pi. You can think of it that way. I think that's the best one to think about. So what is 2 pi minus pi over 3? I don't know. That's a lot of math, Chavez. All right, look. Let's write it. 2 pi minus pi over 3. We need a common denominator, right? So I'm going to change my color just so you can see we're getting common denominator. I need this to be a 6, so I'm going to multiply that by 3. Oh, I need the bottom to be a 3, sorry. So this is going to turn into a 6 pi over 3. See how 6 pi over 3 is still 2 pi? What is 6 minus 1?
5.
So this is 5 pi over 3. What do you think the next one is? 2 pi minus pi over 4. Let's do it. 2 pi minus pi over 4. So I'm going to turn that into 8 pi over 4. 8 pi minus pi is? 7 pi over 4. And then hopefully maybe this one you can do it without having to write anything. 2 pi minus pi over 6. So let's see. 2 pi times 6, 12. 12 minus 1 is going to be... Don't worry. We're going to talk about how you can see all of them are pi. Look at the 11 pi over 6. If you add pi over 6, that would be 12 pi over 6. And 12 pi over 6 is 2 pi. 7 pi over 4, if you add pi over 4, that would be 8 pi over 4. And 8 pi over 4 is 2 pi. You see that? All right. Let's look at the whole unit circle. Let's take it in. Do you see any patterns? I know some of you guys like to be robots. I'm about to tell you how to be a robot if you want to. I see a very obvious pattern. What's up?
Because from the denominators are 6, 4, 3.
Perfect. Okay, so Badet already figured it out. So look, you're going to have to memorize quadrant 1. There's nothing you can do about that. I mean, you don't have to memorize it. You can always derive it from scratch, right? Like we did. But you're going to have to know quadrant 1. You keep the denominators, 6, 4, and 3. And of course the special ones at the axis. 6, 4, and 3, and you just reflect. Look, 6, 4, and 3, 6, 4, and 3, 6, 4, and 3. They all keep the same denominators all the time. Do you see that, guys? In quadrant 2, the number in the numerator, the integer in the numerator next to the pi, is 1 less. Chavez, what are you talking about? Look at the 2 pi over 3. If the denominator is 3, if you're in quadrant 2, subtract 1 from 3, 2. The denominator is 4, subtract 1 from 4, 3. If you're at 6, subtract 1 from 6, 5. Cool? If you're in quadrant 3, you add 1. The denominator is 6, add 1, 7. Denominator is 4, add 1, 5. Denominator is 3, add 1, 4. Chavez, what about quadrant 4? Is there a pattern? Yeah, there is. If you want to keep with the same pattern and focusing with the denominator, double the denominator, subtract 1. Double 3, 6. Minus 1, 5. Double the 4, 8. Subtract 1, 7. Double the 6, 12. Subtract 1, 11. It works. Why does it work? Well, because if you double the denominator, that's like your 2 pi, right? 12 pi over 6 is 2 pi. And then you're just subtracting 1. So there it is. So write that down so you can know how beautiful math is. Math is always beautiful, miss. The patterns don't lie. Numbers don't lie. They're in there somewhere. All right, how are we feeling, guys? Do you feel that we can take another dosage of notes, or do you gotta let this sit in and soak up?